Well, hello everyone, and welcome to this RETHINK live session on CO2 and commercial and industrial refrigeration. CO2 has been at the heart of a lot of topics in the HVACR industry for a number of years, as well as it should be because of its low global warming potential, as well as being non-toxic and non-flammable. Well, I'm here today and excited to have this panel of experts with me to explore that topic. I'm Michael Kellerman, Director of Business Development at Danfoss. And I have with me today Derek Gosselin, Peter D., Brian Kelly, and Christopher Brown. Guys, you want to give a quick introduction, and Derek, we'll start with you.
I'm Derek Gosselin, Director of Technical Product Support for Hillphoenix, a division of Dover Food Retail. We're responsible for the guidance of the application of all of Hillphoenix products with a focus on the deployment and development of new technologies with a focus on CO2.
Peter?
Hi, everybody. My name is Peter D. I am the Food Retail Sales and Services Director for Danfoss, responsible for all the food retail end users, OEM manufacturers, and contractors in North America. And that covers all the product lines and services for Danfoss.
Right.
Yeah, good afternoon. My name is Brian Kelly. I am Director of Sales for Industrial Refrigeration for US and Canada. Primary focus is ammonia, but a lot of CO2 as well now.
Christopher.
Hello, everyone. I'm Chris Brown, currently the Technical Services Supervisor for Climate Solutions in North America. I've also spent time as an applications engineer specializing in CO2 startups throughout the country.
Excellent. Well, thank you guys for the introductions. Today we want to talk about the challenges and opportunities with CO2, and with that we want to talk about regulation as well. So for our viewers, we want you to be part of the dialogue. So please, if you look on your On24 platform, there'll be a Q&A box, and we would encourage you to put some questions in. We'll address those during the session and try to get back to you if we don't get to those at the end of the session. Let's give a little bit of context to what we're talking about here today. We know that the state of refrigerants and really the requirements that go around those transitions have been a challenge and a discussion for many in the industry, including contractors, manufacturers, and end users or the owners of these large refrigeration systems. And the United States, along with 110 other countries, have come together in a planned phase down around HFCs or hydrofluorocarbons to reduce those levels through the Montreal Protocol as part of that mechanism to do that. So let's get started with our first question, Peter. From a food retail perspective, could you please share how the latest industry regulations are shaping the trajectory of the food retail industry?
That's a great question, Michael. I think we've been talking about natural refrigerants for many years now, and there's still a lot of uncertainty around the direction it's going. But, you know, we've seen certain states taking that mantle on, right? They're moving forward with it, like California. That are driving these natural refrigerants, having our customers move to these natural refrigerants. And now we're starting to see New York follow as well. And what's happening here is that we're starting to see a lot of our customer base moving to these natural refrigerants, especially on new store builds, right, to meet these requirements that are coming in place. That also creates a gap for them as well, then what they do with their existing stores. So that's a big problem. But I think it's not just about regulation that we need to talk about and focus on as well. It's about the uncertainty going forward, right? As I mentioned, just California and New York making their own initiatives, okay? It's better to go with a natural refrigerant once and for all. Then you don't have to worry about what's happening in the future, right? And I think organizations out there are willing and able to support customers that want to transition to these natural refrigerants like CO2.
All right, thank you, Peter. So as food retail perspective, let's get a little bit of the industrial refrigeration perspective. Brian, if I was to ask you what's the impact brought by the latest regulations in your area?
Yeah, no, thanks, Michael. For the industrial refrigeration side, CO2 is not new to our industry. We've utilized that in the past. But what we're seeing, not only the regulations, but also like over the pandemic with e-commerce and having to get these cold storage facilities closer to the population. As you get closer, then you're seeing the trend to move away from natural refrigerant like ammonia to CO2 transcritical. So It's exciting because it's just another great, alternative for us as a solution provider to be able to, meet the requirements.
Sure, sure. So you talked about regulations. I heard you also mention trends.
Yep.
Anything else you want to add on additional trends that you're seeing then in that market because of some of this?
Yeah, a lot of it for us is the technology, right? The capabilities. What we're seeing is there's a lot more from the monitoring side. I know Peter's group's been doing that a long time on the food retail. We're also seeing that with the digitalization and connectivity where, demand response, right? That you can utilize the technology then to obviously improve on, reduce food spoilage, right? Reduce carbon emissions and things like that. So the challenge we have is the facilities are typically a lot larger. So it's a different mindset too, of getting people, used to looking at a compressor package, and that's maybe different from a central machine room. So.
Well, back over to you, Peter, again on trends. So separate from regulation, additional trends that are then affecting the food retail industry.
It's interesting listening to Brian, right? When he mentions technologies, the IoT of things as well. And they're the trends we're starting to see also in the food retail side, as Brian mentioned. When you start moving over to these natural refrigerants, it brings a lot more technology into the marketplace. And of course, that creates a lot of its own challenges, right? But there's also benefits around these technologies. Now you have more data. You can do more data mining through your IoT platforms. You also get higher efficiency by these distributed systems, standalone control platforms, and so forth, right? So that's what we're seeing in the marketplace. And also what we're seeing from our customers is looking at these technologies, like I said, utilizing it. How can we support the contractors with these data streams that we have, right? Supporting them from predictive, preventive maintenance, as well as getting ahead of it before even the contractor can roll the truck out. What do I need? What is required? And how quick can I get this resolved for the customers, right? And with these technologies as well that's been adopted with these natural refrigerants, also brings in the safety factors as well by using these technologies, right? So you're giving that comfort level as well to the customer, the end user.
Great. Thanks, Peter and Brian. Derek, over to you. What are you seeing in the industry, and then really specifically as an OEM or an original equipment manufacturer, how do you see things?
I think one of the biggest challenges that we have is providing the industry awareness of why CO2 is an option with natural refrigerants. There are some challenges with the different types of application, different types of technology that Peter mentioned. So how do we provide them a clear message so that they have the right information in looking at what their strategy is going forward? One of the other challenges that we have, putting supply chain to the side for now, is total cost of ownership. First price is always key. It's been one of our major challenges because it costs more to do new technology. We are adding electronics, we're adding different things. So we have to overcome that and have a better understanding of where total cost of ownership comes into play, refrigerant management, energy savings, installation savings, just beyond the product or body of the product. So circling back to supply chain, we all know that that's an issue in our industry. One of the things that we're trying to do at Hillphoenix is get out in front of that is how can we get out of the norm that we do today of engineer to order, making all of our systems snowflakes, none of them the same. How can we then go to a platform design, standardize on the design itself, still meeting the refrigeration need with CO2, but standardizing on components, having components readily available, improving the manufacturing of the process of doing it so that we have better lead times, which is one of the challenges we have in the industry today. So, understanding that we can provide the right solutions if you form a really good strategic partnership with your providers versus just a transaction. How do we get something more than just the product? How do we get the total package?
We probably could have a whole nother session to discuss supply
We
chain.
certainly can.
And Michael, before you move on,
Sure.
I just want to touch on what Derek just mentioned. I think it's very, very important about first cost, okay? Because there is a huge step change for this industry here in North America that really hasn't impacted other regions like Europe, okay? And what do I mean by that is when you're introducing these technologies in North America, you're introducing the likes of case controllers, pack controllers, distributed systems. These controls normally weren't part of your package today, right? They're centralized systems, okay? So that's a huge increase of cost, first cost. But what we need to take into account is the benefits of all these technologies, as I mentioned. And it's interesting what you were mentioning there about, standardization, right? So by bringing in these technologies, now you are standardization more so than a centralized system, right? So Chris would talk a lot more about it. And what I mean by that is, instead of having your system manager, controller, your EMS controlling everything through I/O modules, right?
Yep.
Now you have these standalone control pieces, giving you more data. And if anything is impacted within the store, the rest of the assets will still continue running, right? But it also brings in the safety factor. Not only the energy efficiency you can get from this, that also needs to be taken into account when the end users are looking at these first costs, right? Even down to truck rolling. If you get the IoT right and the data right, you can save a lot of money by not having these trucks roll when you really need them, then let them roll. So all that has to be taken into account, I think, by the end users when they're making these decisions to move to natural refrigerants. And again, it's how can we help standardize it, right? And that's difficult because of geographical areas and so forth. And that's why it's not just CO2. There's multiple natural refrigerant solutions you can use. And back to what you said, partnerships are key to help guide you through that, right? And that is how we all work together as a manufacturer, as a supplier, to the OEMs, to the end user, the contractors. It's making all that work together. And also try and bring that high cost down.
Great points, Peter. Well, we're likely to have people on this call today that have worked with CO2, either dabbled with different architectures in the past, perhaps in the last few years, as well as rolling out some of their first stores now in North America here. And then we've got another group of folks that probably haven't dipped their toe into it yet or are very hesitant to get into CO2. So I'm going to open this up to everybody here. And I know we've been kind of touching on that, but any advice or other things you want to add to how to get started tackling CO2 if you haven't been into the journey yet?
Well, I think the industry has been pretty open to having end users negotiate or relate with other end users who have done it to learn it. You can depend on a relationship with your service provider, your contractors that you have. Do they have experience in it, what their challenges are, what they've seen? As well as your OEMs. I think it's important to look at all options and look at all avenues so that you can have the best information available to make whatever your strategic plan needs to be.
I think that's very important, Derek, as mentioned. And you're right, Michael. We have touched on it, in the last few minutes, but it's partnership from the start. It's working together, right? Because we've all learned, right, from the previous experience, and you learn on your mistakes, right? But it's building up those relationships from the very start. Is it the right application, the right product line? How are the support functions put in place from training? And then the training factor also doesn't stop on the new install, right? You have to train the service contractor after the fact. You have to train the staff in the store. What should they be looking for? Very, very, very important. So it's that working together will make that a better experience for you. But as in Danfoss, and I know also with some of the OEMs, is we also have support functions to support the startup of the applications, especially on these new applications, right, like natural refrigerants. But it's not just to do the startup. They're there to help support, to train, right? It's all training. It's step back to train people. And I think the more we can get in front of that out there, the more skill sets we're building up in the industry. And in the long term, that's going to make it a lot easier for everybody to transition to these natural refrigerants.
Great. Well, guys, I may have opened up a can of worms here. we got a question coming in on the supply chain topic, so we're going to take that one. Again, anybody can respond here. Do you feel that the current supply chain issues will prohibit end users from transitioning to transcritical CO2 in the fear that they may not be able to get replacement parts?
That's a great question, right? I mean, I think from a panel perspective here, and I think we've got to go and will the supply chain question come in, and here it is, right? Yes, it's again, yeah, it'll have an impact, I think, but not a major impact. That's why we have this collaboration working together, right? We've got to be forefront with everybody. It is a global situation, right? So this is where we need the end users to support us and understanding what are their future plans, what are the requirements, needs coming, right? And I think the advice personally I would give at this stage, if you're looking at natural refrigerants in new stores, maybe that's what you need to focus on in the short time and maybe not look at these large retrofits or remodels because the stores are up and running, right? You're building new stores, you're moving to natural refrigerants, let's move that way. But I think from a Danfoss perspective for food retail, I'll let Brian answer on the IR side but we've been working very, very closely with our OEM partners in meeting their urgent need. And it is a day by day, it's week by week, meeting those needs so that we're not trying to miss these deadlines. I think the other point here as well is that I heard service parts, right? Availability after the fact. Again, we're trying to make sure that where there's this geographical area or where there's an area that there is these technologies, we want to make sure that there is products available, right? And I'll say it here on camera, we have a small percentage that we do set aside for emergencies that are service replacement. Please don't call me looking for spare parts, right? We have a department for that, but we have thought of that. But it is a pain point, and we can't get away from it, right? We were at Atmosphere this week. It's a pain point with everybody. And again, it's partnership and working together is how we're going to get through it. It's not going to be there forever, right? We're all in this together, even our competitors. We're all in it together. So we got to work together to get through it. Brian, what do you see on the other side?
Well, what I stole your line. I'll give Derek credit. I love the snowflake analogy. I did hear that, and I agree. The partners like coming up with creative solution where we can meet the requirement, but more of a standardization. So it's not a custom, it's a one-off. And then you have to start all over again, which again, I think is adds the right complexity, right? So I think in that regard, I like that analogy, but I like the strategy, right, to do that. I mean, on the IR side, sure, we're struggling just like everybody else, but I'm excited because of obviously investments from what we've done on our product line for the future to meet the future capacity. So we're definitely trending in the right direction, and no, it's an exciting future for sure.
I also think isolating CO2 in this isn't necessarily the right way to look at it because a lot of the electronic components in particular aren't just dedicated to CO2, they're components that are used on standard systems as well. So I don't think it's necessarily something that we isolate CO2 as negative with the supply chain issues.
And I'd add to what Chris said, that it's not necessarily just refrigeration in general. Whether it's an HFC, HFO, whether it's CO2. I think the big thing we've learned from the pandemic and everything is supply chain. When we talk about the limitation, we used to do just-in-time manufacturing. We had plenty of remote components. Everything was available. When the pandemic hit, that changed. So we have to learn from what that is. And I think part of that is understanding the pain points. We still have an obligation to meet our end users' need for refrigeration. To Chris's point again, whether it's HFC or CO2, the components doesn't matter. So that if we have the ability to standardize and come up with common components, common designs that allow us to take at least half of our portfolio to provide quicker solutions, could be a result of that.
Yeah, that's very important.
Well, we're gonna keep going on this. We've got some great questions coming in, so thank you everybody for the great questions. I'm gonna grab another one here. Very similar, another topic that's top of mind. What do you all think about developing different certification learning programs on CO2 refrigeration for North America? And also possibility of global certification for CO2. Do you think CO2 manufacturers could come together for such programs to approve it for the industry?
Well, I think the industry needs to do that together. I think we as an industry need to partner together to make sure that we are attracting and recruiting new talent into the industry in all of our trades, because it impacts a lot of different areas. As far as with Hillphoenix and our learning center, we have done that. We've done that with a couple of key retailers that we have strategic partners with, that we have a certification program for them, that all of their installing contractors have to take this course, be pre-certified before they can bid on their CO2 projects. So I think we can expand that across the industry so that we train the technicians that are needed to support the growth of CO2.
I just add to that. I think the other side we also need not forget about. It's a refrigeration application.
Sure.
Right? HFC, CO2, whatever, it's refrigeration. And the basic, you get it. Okay, there's different pressures, There's more controls, right? So there is that training. And Derek touched on, the industry is coming, I think, together in certain, they're definitely trying coming together. And if I look at it from the North America Sustainable Refrigeration Council, right, or nonprofit group, that was formed to help support natural refrigerants for food retail, right? And that is a big discussion in our group about how do we get the talent skill? How do we help support the industry and bring them into the industry and have them trained, right? So I would recommend anybody to go onto their website. There is a working group around training and contracting, and there's a lot of material there. Derek mentioned about, Hillphoenix, about their training center, right? I think all the OEMs, Danfoss have training, our competitors have training, right? Maybe there is that collaboration, maybe we can pull together, but how can we help the training colleges, right? As well, providing them the material, maybe even the products to help support them to get out there, right? But it takes everybody's effort. And I've said on a lot of groups talking about training and skill sets, that also means the end users have to be part of this discussion as well, right? We have to come together as an organization. We hear it from end users, I want to move forward, but we shortage. Well, help us. Let's come together as an industry. And I think that's what the NSCRC is trying to pull together with the end users as well, right? So I think it's a big step. I think we're getting there in small chunks. Sure. What's the answer? I don't know. Are the other programs maybe, Brian, that we could look at?
Great question. For us, from the industrial side, we also have to include our organizations like RETA and IIAR, where we can also support those organizations to help them support the technicians and get that training. So we have to do our part too to make sure we're supporting these organizations and that have been around, like ASHRAE, a long time, right? And make sure that we provide them the tools as well.
Sure. I'm going to take one more here from the audience before we dive a little bit deeper. Brian, why is CO2 not so popular in the industrial refrigeration sector?
I don't know that it's not so popular. I just think sometimes there's restrictions like size of scale, right? Size of the facilities. I think that might be part of it. Part of it too is maybe nomenclature or vocabulary. I think people don't understand the transcritical CO2 system and maybe get intimidated by it. So I think there's some education we need to do on our end. We are part of Atmosphere America. We saw a lot of great applications and installations. So part of that, I think, is just the education side of things. But I think there's definitely opportunities as well. And again, there's a right fit and right application. And it's not new to our industry, but there's definitely things that can be done. And I think our partners are educating the end user, like you can do the ammonia, you can do CO2, and then they look at it and see what's the best fit.
And from that side, there's a couple of different sides to your point. One of the things is restrictions. So when you look at big distribution warehouses, their loads are so massive, it's hard to have the capacity in CO2 to get there. But CO2 has made inroads in the industrial market in micro-fulfillment centers, smaller distribution centers, manufacturing or food processing plants, because you can capture the efficiencies of CO2 with it being an A1 refrigerant without having the issues and so forth of ammonia. But ammonia does provide that large capacity efficiency that's hard to beat.
Well, I'm sorry.
No, just in addition to, we see it on plant expansions, and then you'll see CO2 transcritical systems as well. So there's opportunities for sure.
Well, thank you, audience member, for that great question. Derek, let's go back to you then, and we're going to a little bit deeper here and ask for your expertise on systems here. Can you give us a short summary, it's hard to do, on some of the different CO2 refrigeration designs?
Well, I think there's a lot of different CO2 designs out there in the marketplace, but I think some of that is the transition and learning that we've had. We started with natural refrigerants of glycol, then we moved into secondary CO2, then into CO2 cascade system. And they were all great steps to reducing the use of high global warming potential refrigerants, where CO2 booster then transitions into eliminating it, not reducing it, eliminating it. So I think from that point of view, we've grown in the technology used. And then now we have CO2 booster. We know we had a warm weather challenge, but we've overcome that. We've got adiabatic gas cooling. We have parallel compression, ejector technologies. They all improve the efficiencies of the system. But we also have to take that to the next level, is how do we improve the efficiency in the total store? And what I mean by that is, and what was discussed a little bit at Atmosphere, is how do we better use heat reclaim?
Yeah.
You know, dehumidification and things, adding heat to the store. How do we then take and tie in HVAC into the natural refrigerant world? And then also developing a really good building control strategy, because we are adding case controllers to all of the electronics and EEV valves with CO2. So you need to redefine what your control strategy is. And if that's done right, it does give you an efficient building solution.
Thank you. Well, let's stay a little bit technical here. And Chris, I'm going to come back to your
Sure.
expertise. When selecting a CO2 design or a CO2 system, what are one of the first factors that would influence that decision? And what do you recommend to the audience here? What do you think's on their mind?
It's probably a little bit to what Derek just mentioned. It becomes regional and very much climate-based in my mind, because we know that as the refrigerant in the CO2 state goes into a supercritical range, that it becomes less efficient than an HFC system. And the more time we spend above that critical point for the refrigerant, the less efficient it is. So we need to do everything we can to try to keep it below that point. And in years past, that meant possibly a cascade system as opposed to a transcritical system, especially in the southern parts of the country, which still left you with an HFC refrigerant in the building. But now in recent years, the same things you just mentioned, ejectors, parallel compression, adiabatic gas coolers, these are all technologies that have now been introduced to allow us to overcome some of those climate issues and concerns in the southern climates without having to introduce an HFC refrigerant into the mix.
Derek, anything you want to add to that? Any other factors to consider in that CO2 design?
Well, I think the CO2 design, and again, the application of CO2, one of the things that we have at Hillphoenix is a wide product portfolio, because we know one solution or one product won't fit everybody's needs. So we have a range from single CO2 condenser units that are available today in the US market, as well as all the way up to the ETO snowflakes for industrial applications. But in the middle, we have a really good core products that are platform, that are pre-engineered, pre-designed to allow us that flexibility for small formats, convenience stores, as well as supermarket applications. So it's important to understand what your requirements are and what is the right product to apply to that. Then you can move on to the technology and stuff to make it right for the efficiency of your store.
Michael, can I add to that? Because that's interesting. When you talk about portfolio and applications, it's important. We started off the discussion about CO2 in new stores, and we know there's a big gap with the existing real estate that's out there, right? But again, I think, Derek mentioned, that range of portfolio offered by the OEMs, right? There is solutions there that possibly could be suitable for a retrofit solution, right? Sure. And that also was brought up in the conference this week, right? How do we get that standardization in there for these retrofit models? And you mentioned CO2 condensing units being discussed for a long time. I think they're finally starting to come to the market. You just mentioned you have your own unit. We've seen a couple this week. So again, I think it's partnering up, sitting down, discussing the requirements, and all this expertise that's out there is available to help end users make those decisions, whether it's new stores or retrofits or remodels. It's there. It's working together and collaborating on your needs and requirements.
Yeah. And when you look at having a wide portfolio, it's important because, traditionally CO2 is a centralized system. And that's great for new construction. You can plan accordingly, you can build, whether it's on the roof and in the mezzanine. But the current retailers have a current fleet of stores that they have to get out. And how do you transition and do a remodel program? So with having the flexibility of some of our products, we can now move them into distributed system CO2. And that allows them to do a stage remodel, keeping your store open while moving to a natural refrigerant. So again, flexibility in what the products are and what they need to meet for obligations, and that gives you that flexibility.
Great. Well, we've talked about some design considerations. If there's any others, please feel free to mention them. But what about some of the safety precautions that shouldn't be overlooked when dealing with CO2? And I know we touched on certification, or the great question about that, but any other safety precaution related issues we should be thinking about?
I think from a safety perspective, from from the application design and the electronics, right? Controls. The safeties are built in. There's safety regardless whatever application you're working on, right? But I think, everybody needs to be aware that the safeties are taken into effect in these technologies that are being used today, including mechanical, right? And valves and so forth, right? That comes down to education again, right? We're back to it. It's still a refrigeration system and application, right?
Yeah.
It has different pressures in certain areas. It's just down to training and that knowledge. And like any of the control system, any of the applications, the safeties are already built in there to take that into account. Chris, would you agree with that?
That's the first thought that comes to my mind too, is just the training. It's when someone comes in and now knows from training that they're dealing with higher pressures, that there's relief valves in the system to help provide a level of safety there, that they know what they're dealing with and they're not walking in and being caught off guard by the fact that the pressures are so much higher. And then on the walk-in side, we know we have leak detection typically in the boxes there to prevent not just maybe contractors or technicians, but employees, stock employees and whatnot as well. So like you said, there's the level of safety that's needed a lot of times is built into the system design and the controls that are a part of that.
Well, we got a good question that just came in here related to this topic. Is emergency external storage or release part of current transcritical system design? I think you touched on that, but anybody want to add to that? Emergency external storage on current transcritical design.
I would probably say there, Michael, that when we first started off 10 years doing CO2 systems, we had to make sure, because we want to use Coleman grade purified CO2. We don't want to use beverage grade. So what we want to do is make sure we have available supply. That has changed. More and more supply houses are now stocking it. So, the direct need of having an inventory on site still may be a priority if that's what the customer needs. It is a low cost refrigerant, but you still have the cylinder charges. But as an industry, we're looking at how do we get more supply closer to where the CO2 stores are. And I think a lot of the supply houses and gas companies are working towards making sure that that's not an issue.
I think that's also important. You just mentioned, right? Yes, many years back, we had to make sure that supply was available. But as the demand increases, and we've seen an increase in the requirement of natural refrigerants like CO2, the supply houses are also supporting it. But also more important as well is down to the design and the applications as well. If you're going for distributed systems and you might have multiple, right? Well, then you're not losing the whole charge for your whole store, right? Okay, there's a section gone down, right? But then using those kind of multiple distributed systems, now you have standardization as well, right? So again, it's what is the factors you need to take into account as a customer, again, to design to help you, right? Are the techs available? Do I really need this charge? You mentioned it. If it's one CO2 rack system, maybe you might want to have that charge available, right? If it's multiple distributors, maybe I don't need it because I'm not going to lose the whole store. So that's all in the design factor and your needs and requirements. That's what I see. Yeah.
Well, guys, this has been a great discussion so far. I'm going to go around and ask everybody to wrap it up and just give us a main point or piece of advice that you think our audience members should take away from today. So, Chris, I'm going to start with you.
I would just say not to look at this technology, this refrigerant, these designs as something that's that much different from what we have today. Sure, there's some differences, but I'd say even with HFC systems, that there's differences from system X to system Y a lot of times. And so not to look at this as something where you have to start from square one. It's another refrigerant system, like you've mentioned multiple times here, that has some training around it that will definitely help you get up to speed on it quickly.
Brian?
Yeah, no, for me, it's exciting time with all the new technologies. And for me, it'd be more of a push for engineers or people maybe that don't want to go to university or whatever, that want to get in. It's an exciting field for us, whether it's on the food retail side or a store side or from the industrial side. It's a great industry, and there's so many cool technologies that are coming, and really exciting time to be in the industry.
Peter, how about you?
Yeah, I think just, not to repeat the guys, but, he's taking advantage, number one, of these technologies out there. Brian said it's an exciting time because There's a lot of IoT platforms coming into play as well with this technology. So that makes it exciting because now you have this data mining and so forth. You could do a lot, right? And you know, we're all here to help. Training, you mentioned, not going to repeat it again, but I think the biggest thing to take away here is the experts out there. It's not new anymore, right? It's there, it's proven, its technology is being used. I think it's just us collaborating and all working together to meet the needs and requirements of the industry and the customers that are out there. And that collaboration has been going on for a number of years. And I think that's why you see a lot of end users have been very successful in transitioning to these natural refrigerants like CO2.
Yeah. Derek?
I would probably have the message that change is here. It's not coming, it's really here. And what are you doing as an end user to prepare for that? You can either be proactive and start to investigate your options, your designs, how that works and aligns with your strategic plan, or you could be reactive and just wait and see what happens when regulatory pressure makes you do it. I don't think there's any right or wrong answer, but it's also good to understand that, to Peter's point, the technology, the application, it's out there. We have a lot of systems in North America, a lot of systems globally running. It is an option. And if you really want to build your store of the future today, it's available.
Great. Well, let's see if we can take a couple more questions from the audience, and we have a little more time here. So let's. Here's a good one. What are the general experiences or feedback from customers after implementing their first CO2 system? Good question.
Well, and that'll vary. And there's a lot of things to that, Michael. Maybe, yeah, you have your equipment manufacturer, you have your contractors, you have your installation people, you have the knowledge base. And I think that's improving as we go. But having the equipment is one part of it. Having the right design, working with your engineer of records to make sure all the crossing T's, dotting I's, to working with your contractors to make sure they understand the application and the installation, because it takes all of those components to put together to work smoothly to create a positive thing. But there's also a good thing about lessons learned. You know, don't be feared by one, just understand it, correct it, and come out with a solution to make sure you can make it repeatable and make it a smooth transition.
Well, we're going to ask you to keep the questions coming, so we've got a few minutes left if you guys have any other questions. Here's one that came in. We talked a lot about CO2. This one is asking, what about costs associated with propane systems or micro-distributed as compared to CO2?
Well, from Hillphoenix point of view on that side of it, propane is another good natural refrigerant, okay? The one problem with it now is the charge. It's a 150 gram charge, which means really it's applicable to air-cooled self-contained applications, or it's been done with micro-distributed designs, okay? Because you're putting one unit on a case, doing a water chill, you can keep everything under the 150 gram charge. There's a lot of push and movement now, and we're waiting for regulatory finalization, if you want to call it, whether we can go to 300 gram and 500 gram. That will change a little bit, but it will apply to mostly air-cooled self-contained and micro-distributed designs, because you're not going to be able to put 2,000 pounds of propane in a centralized system. Not going to happen. But what it does do is it gives a natural solution for somebody who may not want CO2 and give them options with other natural refrigerants.
Okay. I'm sorry I'm laughing at one of the questions that came in here. I'm not going to focus on it. They are asking about how I keep my hair nice. But whoever sent
You sure that wasn't for me?
Yeah, I'm going to ask Chris.
How long do you take?
Okay, so here's one. I think we were talking a little bit this week about it. Are there any new A1 refrigerants being developed that will make CO2 obsolete?
Pete, you want to make a shot at that one? I mean, you know, the A2Ls are coming in, but they're still mildly flammable. You know, the A1, I'm sure the chemical companies that are making it might have something to try to get into that. I mean, if you look at where California is with 150 GWP or less, or whether or not the AIMS Act targets that or has a higher limit, you've got to have the A1 be under the 150. And I don't know if you can get there without either a natural or an A2L. And I think that would be the challenge, but I'd be open to be advised by other chemical companies or refrigerant manufacturers what their plans are and their options. But the good news is CO2 is enabling.
Yeah, I think that's important. It's again, uncertainties, right? Where do you want to take your business? And that's a decision you're going to have to make yourself. You know, there is so many different opportunities for you to look at, right? You've got to make that decision, right? We as, you know, teams here can only support and give advice out, and you've got to make those decisions.
Okay. Here's another one. I think we touched on this one, but let's just make sure we clarify it if we didn't. Do commercial CO2 refrigeration systems use a special grade of CO2? Is beverage grade used in beverage carbonation adequate? I think you touched on that maybe.
What we use is Coleman grade CO2. We recommend it's 0.9999% efficient. The problem when you use beverage grade, it has a moisture content, so you have to filter it. If you don't, you are injecting non-condensables into your system. And as any refrigeration technician will tell you, that is not what you want because it has air gaps and creates a lot of issues with your performance. So if you were to use a beverage in an emergency, you would certainly want to put it through a filtration system to make sure you're taking out the impurities.
Even worse with CO2, it can react with it and result in carbonic acid, which is going to eat into your components.
Correct.
Yeah.
We'll keep the questions coming, everybody. These have been good so far. And you can ask about other guys' hair on the panel as well. So this one, again, I think is a spin of one we've asked, but we talked about propane versus CO2. This one is asking about some of the financial implications around going to CO2. First costs, additional safety. Is it a wash going from HFC to CO2? And if not, why? Or should we be taking a bigger look at that? I guess?
Well, I think anybody looking at it needs to invest the time to understand what their base design is, because every ROI, every comparison will change based on what that end user has as their base model.
Yeah.
So one of the things that Peter had mentioned earlier, and you had mentioned, when we go to CO2, we're adding case controllers, we're adding electronic expansion valves. That is a cost center, but it allows you to adjust your superheat. It allows you to have better case performance. It gives you all your set points you need, and you're running to the maximum performance of that case. Then when you look at it, the system side is, there are some things. We have a high pressure control valve and a bypass valve, things that we need to do to make sure that CO2 systems work, because they will work in any environment. It could be 120 degrees out and it'll still work. It just won't work as efficiency because it can't process gas. So other than that, and Peter mentioned this early, some of the things we do on the high side, from the rack to the gas cooler, and the gas cooler is a little bit more money because it is rated for a higher pressure. So there are some things that do increase the cost. Now, on the flip side of that, Michael, is you got to look at installed costs, okay? Not just your capital costs, your installed costs, because now we know pretty much on average you can save 10% of your installed costs because the refrigeration lines in your store are 1 or 2 sizes smaller installation, smaller pipe hangers, and less labor to install. That helps you offset that. Then you have your charge startup. If you're doing 2,000 pounds of 448 or 449 at $20 or so a pound versus 1,700 pounds of CO2 at $2 a pound, there's a big difference. So again, it goes back to the original stuff we talked about earlier, total cost of ownership. You can't look at first cost. You got to look at the total installed applied cost and where the benefits come on efficiency, refrigerant management, and all the things that make up your total cost of ownership.
And that's important. When you're using these technologies as well, and we mentioned like case controls and so forth, that's how the first cost. It's also the efficiency you're going to get. It's proven that you can get 11 to 15% energy efficiency using electronic expansion valves with case controllers. But they got to be set right? They got to be optimized. And that also then allows you, because you're using these technologies, you're using your IoT platforms to monitor your store and manage the efficiency in your store from that point, right? So again, we talked about it, right? That will also help you maybe cut down on your service costs by running trucks. So you got to take that all in. And, we've seen customers that have moved to these technologies and these natural refrigerants have seen these advantages, right? And that's where they've calculated the return of investment. We've seen that particularly in other regions like Europe, where they've seen pushing it out because they see that efficiency. Now, somebody might say, well, okay, the cost of energy is a lot higher in Europe, right? But you know what? It's changing here as well. So you got to be prepared for it, right? Nobody knows what's around the corner. Regardless whether it's still a low cost of energy, right, to purchase that, you're still getting your energy efficiency by 11 to 15% just using these technologies.
Yep.
You mentioned piping installation, wiring, and controls installation. We've seen studies that it's cheaper as well, because now, instead of a centralized control strategy where we have tons of wiring running throughout the store over long distances, we're now just talking about 2 wires to each point, each circuit to hit the case controls, which is much less wiring and much less installation time, because so much is done locally at each case in the store and then up at the rack as well. So there's a significant savings in wiring as well as piping that factors in all of that.
Well, here's one that just came in. I'm going to paraphrase part of it. It's pretty lengthy, but it's getting back to training. And it's making the point that a lot of the manufacturers offer very short trainings, virtual or maybe a class, 4 to 12 hours. And there's plenty of HVAC schools and training out there, but not so much for refrigeration. This member here says, I want to find a commercial refrigeration training program. What happened to the refrigeration training programs that were formerly available?
Can you repeat that before the what?
What happened to the refrigeration training programs that were formerly available?
I would say, I think there are a few that are out there, but primarily most of them are for HVAC, all right, and air conditioning, which is not at the level of the technician. But I think that's part of what we had talked about earlier, about the industry needing to work and develop with other partners, education systems, training facilities. How do we get that program in place so that we can get people attracted to a trade school that has refrigeration as part of their curriculum, so that we can start to bring on the new generation of trained technicians? It's a challenge we have. It's an industry challenge, and that applies to whether we're doing CO2 or DX refrigeration. We still don't have trained trades. So we need to work on that. It's a very good point. I know the industry's aware of it. Peter mentioned it earlier. The NSSRC, the North American Sustainable Refrigeration Council, are working with manufacturers and end users to find out how we can bridge that gap and at least start to develop what we need to support the future.
All right, let's take another one here that came in. This is a good one. F-gas refrigerant industry is now promoting A1, HFC, HFO refrigerant blends that are considered mildly flammable and already have planned use for A2Ls in the very near future. In both cases, the common message from the F-gas industry is a simplistic statement that CO2 is inefficient. Other than what we've already been talking about, is there anything else that you can think of that the industry can do to correct this misconception? Thank you.
Yeah, that's a very good question. And here's how I would probably want to answer it. Keep in mind that you've got to understand what the application is and so forth, okay? Where regulatory is going, if you look at those A1 refrigerants that are in that 1400, 1300, 1200 GWP, they will be obsoleted. So is CO2 inefficient? Well, yeah, if you're doing no technology and put it in a warm climate and don't do the due diligence to make it efficient, it can be. Most of the adoption of CO2 uses the technology, adiabatic gas coolers, so it is as efficient and will be your future-proof solution, where the A1s will not.
I would even beat up training again a little bit on this one, which we've been talking to ad nauseum, but there's a system that can run and function, and there's a system that can run appropriately the way it was designed. And so when these systems are going in, if they're not being maintained and run at a level that they were designed to, then they're going to obviously present themselves as being very inefficient.
Yeah. But that's any system, right?
Yeah.
If you don't set them up the way they're designed to,
yep.
Right? They're going to run inefficiently, and you're going to have higher costs. And there seems to be a lot of focus coming in on, and it's still going on. We've been talking about this for 10 years, right? About CO2 being inefficient. It's not if it's set up right and you use the technologies the way they should be used. And Chris is right. It's not just set out one, walk away, I'm done.
Yep.
You've got to monitor it. You've got to keep an eye on it and make sure that it's there. And that comes down to trading, making sure the contractors understand by tweaking a system has another impact on their customer, which is energy cost.
Definitely part of it. And that goes back to originally what we talked about is industry awareness, overcoming the myths. You know, what I would question if somebody has that question of, hey, use this refrigerant because CO2 is inefficient, ask them, what are you comparing it to? What is the design? What is the baseline? How does that impact my design? You know, and when you do your due diligence, do your homework, and strategize on what you're comparing to, you can find that CO2 in almost every case can be energy efficient no matter what the climate is.
Great, great. Well, we got to wrap it up. I know everybody could keep talking on this subject. So I want to thank you guys, our panelists, for being here today and ones that have traveled in. And I'd also like to thank our audience members for tuning in today and for some of the great questions and the funny questions. Again, as an audience member, if you would like support on your journey into the green transition, please feel free to reach out. We would love to support you on that. And then lastly, we will have additional Rethink live sessions coming up next Thursday, June 16th, from starting at 12 p.m. Eastern time. So join us for those sessions as well, and you can check those out on the Danfoss website. So again, I'm Michael Kellerman. Thank you again to everyone, and have a great rest of your day.